I'm thrilled to welcome you again to this event. As you know, Kingdom of Morocco is facing significant water crisis as traditional forms of supply, such as groundwater, become ever more stressed. Unconventional water resources become ever more critical in meeting the demand from sectors seeing growing activity, for instance, OCP Group. In this context, OCP Green Water was launched to meet the growing industrial water needs from unconventional sources using green energy. To kick off this side event and to share with you more insights on the topic, please join me in welcoming our keynote speaker, Mr. Ahmed Znibar, the Managing Director of OCP Green Water, and Mr. Abdelilah Bouziane, Managing Director of JESA Building and Infrastructure. So, yeah. Okay. So, please come here.
Good morning, ladies and gentlemen. First, I would like to express my gratitude for the privilege to have today the opportunity to share with you the OCP non-conventional water program experience, which has evolved over several years and under various contexts. Before going through into the main subject of unconventional water, allow me to provide you a brief overview of the OCP Group, which is a century company and a global in the fertilizer industry today. OCP as Moroccan company has held a prominent position as an international leader committed to sustainable development, providing effective solutions for agriculture and fertilizer industry worldwide. To get a better understanding of OCP businesses, let us show together some key indicators that define the OCP Group today. The group has exclusively access to 70% of world phosphate reserve, which has a responsibility toward the planet. In this regard, the group holds around 27% share of the global market and achieved a revenue of $11 billion in 2022. To consolidate its leadership, OCP continue to invest in green program, investing around $13 billion between 2023 and 2027. The investment, this investment is aligned with the third with S curve, which is launched recently, aimed to reinforce its position as a leader in the fertilizer industry and become a global leader in the agriculture business. This involves growth in the rock market, diversification in byproduct, and playing a key role in the energy and the water sector. This new wave focused on 3P, people and the planet positivity, is driven by an ambition to offer reliable solutions in phosphate rock to sustainability, support global food security, create more value, and strengthen the group resilience by diversifying beyond the agriculture value chain, supporting the group decarbonization program, and the global ecological transition, and providing assistance for farmers in sustainability, improving their yield and soil health program, customization application of nutrient. These ambitions is supported by 4 pillars: talent for potential, cost leadership, being digital, and innovation engine. In a more tangible approach, the group has pledged to ensure the carbon neutrality and sustainability of its product through 3 key pillars. The first aim to reach 100% renewable energy across all its facilities by 2027. The second making the shift by eliminating indirect emission associated with its product and their use by 2040 through the adoption of green fertilizer for soil and the planets and carbon sequestration. The third pillar will be high value added product centered, particularly by embracing the circular economy supported by innovation engine, University Mohammed VI, Polytechnic and Innovix. Finally, the group is firmly committed to use 100% of non-conventional water for all its facilities by the end of this year. In order to save water resources, OCP has launched a water strategy since 2018, based on 3 segments: reducing water consumption in all facilities, both in mining and chemical plant, launching several water initiatives and researches and development with University Mohammed VI, Polytechnic and other partners. Decision to use exclusively non-conventional water by end of this year through an ambitious investment program of desalination water, waste treatment, water treatment and pipeline. To reach this ambition, OCP Group has created in 2022 OCP Green Water, aiming to produce and around 660 million cubic meter per year of non-conventional water by 2027. The main purpose is to contribute to reduce water stress by promoting sustainable and innovative access to non-conventional water resources. We target 3 objectives: ensure all industrial water OCP by non-conventional water, and ensure the drinking water for all communities and cities around OCP area, and supplying some arid area around OCP cities, aiming to develop specific agriculture, leveraging the high add value of University Mohammed VI Polytechnic. All those objectives are supported by 3 foundations: sustainable production, expertise, and innovation. Our strategic vision is based on 4 axes: national leader in water desalination and other non-conventional water, green water. Secondly, OCP backbone in ensuring its unconventional water supplying and supporting its industrial and agricultural development, and being central role in implementing public policy in strategic sectors, including urban and agriculture area, and pioneer in development of expertise and in innovative technological and industrial ecosystem in the unconventional water sector. In terms of production program implementation, we have launched 2 programs. The first one is called Emergency Water, launched in 2022. It consists of, first, to securing the supply of non-conventional water OCP chemical platform in Jarf and Safi. For the urban, securing drinking water for El Jadida and Safi cities. For the second plan, it's expansion plan from 2023 to 2027. It consists of securing supplies to the Khoribga Gantour mining site will support in OCP growth in all area to maintain its ambition to have 100% non-conventional water. And also in urban area to supporting the supply of drinking water to other water-stressed region of Morocco in which OCP operate or will operate, such as Marrakesh, Yusufia, Ibn Grir. For the energy, all those programs will be supplied by green energy, which will be produced by OCP Green Energy, another OCP subsidiary created in the same time as OCP Gain Water. For more detail, the water program covers 2 chemical plants at Jarf to feed OCP need and El Jadida city and region. 200 kilometers pipeline under execution will supply the biggest phosphate mine at Khoribga, including urban and agriculture need. At Safi also to ensure OCP need and feed city, a second 200 kilometers pipeline under procurement will be provided water to existing and new mine in Gantour, as well as supply in Marrakesh, Yusufia Ben Grir with potable water. Also, at the south of Morocco, near Lyoun city, a capacity of 60 million cubic meter per year is planned to feed the OCP new chemical complex, the Tarfaya program, including agriculture. Regarding the agriculture, the target volume is around 160 million cubic meter per year to supply arid area around OCP cities. This will be executed through the collaboration between University Mohammed VI Polytechnic in RD and OCP leveraging fertilizer expertise. For this desalination program, up to now, we achieved around 125 million cubic meter per year and ongoing to deliver an additional 120 million cubic meter per year end of this year. The other capacity will be delivered gradually until we reach 600 million cubic meter per year. All those aggressive achievements were possible by the support and involvement of GESA. GESA is joint venture between OCP and Worley in terms of engineering, procurement, and project management, and also other partners such as Ion Exchange, Flowtech, System, MSSA, and other partners. For GESA, I will give the floor to my colleague, Mr. Bouzian, to share with you an overview on GESA and its strategy to deliver the water program.
Thank you. I would like to ask our valued panelists to join the scene. Mr. Alexandre Eventis from OCP Group, Mr. Patar from Ion Exchange, and Mr. Igor Galides from Flowtech. Thank you.
Thank you, Mr. Zarimber. I am glad to be with you here, all. Before I will go through the water, I will be presenting briefly the overview on GESA. So as mentioned by Mr. Zarimber, GESA is a joint venture between two global leaders, OCP as a global leader in phosphate industry, and Mr. Zarimber has elaborated more in detail about OCP, and Worley, which is the world leader in consultancy engineering services for energy, chemicals, and resources. We are part of a global Worley organization with more than 200 locations, and this gives us an advantage of having reached back to a wider expertise on all sectors around the globe. So our ambition is to continue leading as world-class solution providers with African DNA. And our journey began in 2010, and throughout the past 14 years, we have been accompanying client and mainly OCP to execute and deliver flagship programs and projects. And we have been able to deliver the wave 1 for OCP, and we are working on wave 2 and also accompanying OCP in the sustainable move and the green transition. Starting 2016, GESA has started its journey in Africa, and we are aiming to grow more and more our footprint in Africa. In numbers, GESA has more than 4,000 collaborators located in 7 offices, and we are covering a large panel of sectors: fertilizers, mining, energy, water, port and transportation, and buildings. And we have today more than 300 active projects. With regard of water capabilities, we have more than 350 engineers and specialists covering a large panel of services, from water resources planning, flood protection, dams, irrigation, to desalination, wastewater management, seawater intake, and water transport and distribution. The water group is covering the whole value chain, from consultancy to commissioning and startup, and we are also going beyond this through our asset management business unit. Now the most important is to share with you the key success factors that enable us to deliver in very, very short time this huge and strategic emergency water program of OCP. Before giving you some key success factors, I would like to highlight some challenges and constraints that we have been facing through this delivery. OCP has mandated GESA and empowered GESA, which is very important to mention, to deliver and execute these high fast-track programs. Among the constraints that we have been facing was the engineering, because we need to allow engineering to be mature enough. Also, we have been facing long lead item delivery, like high pressure pumps, like VFDs, electrical, like RO-skid, and so on. And also, in this period, the market demand, the water market demand was very, very critical because of scarcity of water in a lot of countries like Morocco. And of course, the logistic constraint was our big nightmare during this journey. And of course, we were relying on our ecosystem capabilities when it comes to civil work, electrical piping, and so on. So to overcome all this, we have adopted and we have implemented some strategies to deliver quality, but most importantly, to deliver the schedule that has been, driven for this program. So we have implemented modular configuration, which aim to supply containerized and SCADed modular system, and which will enable us to deploy rapidly these facilities on the field. This modular configuration has also allowed us to have this scalability and flexibility in terms of capacities, which have also helped us in gradually delivering and answering the need of our client by having this modules configuration. When it comes to engineering or design, we have adopted smart design. So we have worked on the construction, on the, implementing what we call advanced work packaging, which is a front to back, the back to front, strategy approach, which has allowed us to, customize the design to the need of the field. And we have also used the smart design by using cost-effective and schedule-driven strategies. Of course, it's very important to mention also that we have involved in very early stage our contractors and vendors to be with us on a very close way to deliver and to avoid any rework during the execution. And last and not the least, we have worked and we have privileged the plug and play component, working to easy integrate the module and also to standardized connection when it comes to interface management. Thank you.
Thank you, Mr. Abdelah.
Just to summarize, the main takeaway for OCP water and conventional program and conventional water are the following. From the beginning of this year, 100% non-conventional water supply for all OCP industrial facilities. And all those plants to produce unconventional water are fed by renewable energy. The investment, the capex, it's around $4 billion from 2023 to 2027. We have achieved 100 million cubic meter of extra capacity installed in less than 1 year and a half, thanks to GISA excellent delivery and also our other partner. This including 445 million cubic meter of capacity allocated to urban needs of OCP neighbor town, mainly Safi and El Jadida, with a total population around 1,200,000 population, and 55 million cubic meter of capacity for OCP chemical facilities, meeting 100% of their requirement. Also, installation and commissioning of additional 120 million cubic meter of desalination capacity in this year, dedicated exclusively to supply part of Casablanca and Khoribga. And also installation of 200 kilometers of pipeline from Zorf chemical site to Khoribga with capacity of 80 million cubic meter of supply industrial, agriculture and urban needs starting around mid this year. And finally, supporting agricultural activity through the supply of non-conventional water bringing high add value to arid land adjacent to OCP site. Thank you for your attention, and I remain at your disposal for any question or clarification.
Thank you, Mr. Sniber. So now we will share with you a video about the program.
As part of its sustainable development strategy, OCP Group launched a new subsidiary in 2022, OCP Greenwater, to spearhead an ambitious initiative. This new company aims to achieve at least 600 million cubic meters per year of unconventional water production from 2023 to 2027, which corresponds to approximately 1.644 million liters per day. By 2024, OCP Group will fulfill 100% of its industrial water requirements. Using desalinated water, OGW will also ensure the provision of potable water to urban areas in OCP's operations regions. Additionally, OGW aimed to support agricultural initiatives involving high-value crops currently under development through collaboration with Mohammed VI Polytechnic University. This effort will foster economic growth in arid regions. In this purpose and to face the exceptional water scarcity in the Kingdom of Morocco in last years, an emergency plan was initiated to increase capacity by 500% of OCP desalination water capacities to reach 377 million liters per day in less than 1 year. This plan, known as the Emergency Water Program, represents the first stage of the OCP Green Water Initiative. To meet these goals of timely delivery, flexibility, and mobility, a strategic execution mode has been implemented using a mix of modular skid and container configuration, with the implementation of a fast-track execution configuration supported by an integrated, agile organization implemented between OCP Greenwater, JESA, and their ecosystem. The engineering of the desalination units was carried out with extreme efficiency, taking into consideration site's configuration and constraints, utilities required from seawater supply, energy and power supply, as well as the product water pumping and transfer to end users were identified and secured, while overcoming all kinds of constraints such as crossings of railways, roads, and highways. Local authorities' support was a key for such achievement. The signing of several conventions and agreements with the Ministry of Equipment, Moroccan Highways, and the municipalities of El Jadida and Safi in record time allow the project to move forward very smoothly to reach the water supply objective. An exceptional ecosystem was mobilized to carry out the OCP Green Water Program.
Thank you. So, as part of this ecosystem, I will ask Mr. Alexandros Yeventis from OCP Group to join to present you their contribution on this program. Dr. Alexandros Yeventis is the founder of and CEO of OCP Group. He is a PhD chemical engineer, graduate from National Technical University. He has significant experience in the design and operation of water and wastewater treatment system, cathodic protection and energy saving, with more than 60 publications in scientific journals and conferences. Thank you, Doctor, to be with us today.
Very much.
Hello. So it's a big pleasure to be here with you to hear about this big program that we have a part of it, and we are very happy to cooperate with you. So I will have a small presentation about the capabilities of our company, and I think that from all this that we hear already from you, there's a lot of inspiration and a lot of things to be done in the future. And we hope to be part of this journey. So, our vision as a company is clean energy and clean water with innovative combined technologies to develop sustainable solutions for industry and municipalities all over the world. It is very important to see, as you see in the logo, that we are a water and energy company. We are working on this water and energy nexus, very alike of what OCP wants to do as a big industry, that they want to have green water, because energy and water are very well linked together. So what we do, we have 4 sectors. One is the water, where we have water treatment, reverse osmosis, ultrafiltration, advanced medium filtration, and electrodeionization. We are working on wastewater treatment, where we have membrane bioreactors, heavy metal removal, industrial water reclamation, and municipal water reclamation. So we are working on all what we call green water. And in the energy side, we are working with geo-exchange, with heat recovery, with EMS system, photovoltaics, and cogeneration. The most important is that we combine the technologies. So we offer and have a lot of references in systems that we integrated water and energy technologies together as one system. We also have a corrosion protection sector. We're working with impressed current and sacrificial anodes. That means that we can secure all our projects, especially from seawater, from corrosion. And we are also active in the last 10 years with biogas, with anaerobic digestion, deuterization, biomethane, and biofertilizers. So this is the 4 big sectors of our company. So what we can do is we can do 10 key projects for wastewater and wastewater treatments. We are prefabricated water and wastewater treatment equipment. We can make 10 key projects on geo-exchange, ESCO services, energy services, BOO and BOT services, and upgrade of existing plants. So what's our market position? We're right now a leading European manufacturer in the desalination market. We're the leading private Greek desalinated water producer. We produce more than 90% of all the Greek market of desalinated water. We give to industries, to municipalities, to hotels, in the private sector with one-to-one deals, whether we manufacture the equipment owned by the client and buy the water, or even in a leasing basis, or with the equipment to be in our side. We are the leading and most innovative Greek company in water reuse, industrial and municipal, and we have many applications. Some of them are the biggest in Europe. We have a leading European manufacturer of geo-exchange systems. This is cooling and heating with seawater or with brackish water with wells. And our company is exporting more than 50% of the turnover in 30 countries around the world. So we are 220 people, 89 engineers, 20 site engineers, technicians, and administrative personnel. Very fast, you can see our production facilities in Crete. This is our factory in more than 30 hectares, special infrastructure, completely vertical from engineering to construction, and that is something that can give us a very integrated solutions. Our footprint in the earth, energy, biofertilizers, and water, this is what we do. So this is our exports, and what you can see, Morocco, Saudi, and Angola are three new markets the last 2 or 3 years. We had the chance to work with the first project in Zorzafak expansion. We worked and we delivered the Arrow trains, and that was the first successful cooperation we had directly with OCP on this project. Of course, with the engineering of JESA always, but in this case, OCP was the direct client. You can see in our factory we have a special line where we can prefabricate the lines. We can test them with water. In many cases, because we have the power installed, we can also put the system in complete operation when it is smaller, of course. We are discussing about systems up to 10,000 that we can fully put in operation as a modular system. This is very recent. Actually, this is a photograph just taken less than 10 days ago. You see the first train of Wave 2 is ready. It is tested. Actually, right now, it's already shipped and is going to Casablanca. You can see in the other picture the 4 trains under manufacture. So we manufacture in parallel, and we are in the schedule to deliver all of them by mid of June, the 2 trains and the other 2 trains by the end of June. To have this extra fast project that in 5 months we will deliver all the equipment for the 60,000 cubic meters. I can show you some other examples. For example, this is a 10,000 cubic meter plant in Santorini that we also completely prefabricated, and we also installed all of it, and now we have 1 year of operation also. You can see other units that we prefabricated in the Caribbean. You can see here in refineries, this is a 15,000 cubic meters per day. This is actually the biggest plant for a refinery in Greece, but also one of the biggest aero plants in a refinery. And that is not a joke, because most of the refineries, they have evaporation. we have proven, and now most of the refineries, they do that it is much cheaper to do it with reverse osmosis and much more reliable, even when steam is for free. And that is a very big example. This is one of the biggest EDI systems of Europe also. It is 15,000. There is no conventional designs. It's EDI systems. We design, we construct this system. And one more innovation. It is the biggest combined geo-exchange and reverse osmosis system. We are taking the water for cooling, after cooling of the refinery. So they pump the seawater, they cool the refinery, and the hot water actually returning to the sea. This is what we use. This is a unique application. There are only 2 applications in the world with many advantages. This can be also a very good idea for Morocco, because this is a very good idea about how you combine cooling and heating with reverse osmosis, and you have a very, very big advantage on this kind of combined systems. You can see this is a brackish water source in Crete. We have in the Red Sea, in the Emirates. Here is a very interesting, this is a very big reuse project that we are giving in a golf course, 1,500 cubic meters per day with a UFRO from a sewage plant. And we make water which is actually potable, but we give it for the golf course, and we take the fresh water for the people. We also manufacture very special reverse osmosis, for example, for leachates. So there are very special reverse osmosis that they can treat actually effluent, and they can concentrate. What I would like to say a little bit about, giving a more general idea, that in the world that we are here, and you can see it's the dream also of OCP, we have a sustainability challenge. The challenge is water, is the waste, is energy. Availability, cost, quality in the water is not only the availability, it is the cost and the quality. The waste, recycle, reuse water, energy production, safety and cost. And the energy, again, cost, availability, compatibility with renewable energy source with existing infrastructure. Water is not only the main element of life, but also a unique energy source. And this is also an example that I would like to show you how we have to see water. And I'm very happy to hear about this very innovative project of OCP and JESA to work on the water and energy nexus. So water can be used for thermal energy. We can exchange heat. Water can be electrolyzed and produce hydrogen. Water with a hydropower, with a movement, can produce again energy. Also, with energy, we can make fresh water. Actually, reverse osmosis, only energy is required. We can clean wastewater. With the modern technologies, again, energy is needed and membranes to clean. And of course, something more magic, whatever you put organic in the water, by itself, it will produce biogas, energy again. So water is a magic element. With water, we can produce energy and we can store energy. Energy can produce fresh water from the sea and clean any contaminated water. So this is what we call the water and energy nexus, and this is what I think it will be the future of all the world. The challenge is decarbonization, is decentralization and digitalization. And the green industries of the future, they have to work on the water production, on the water reclamation, on the water as energy source, and the zero and liquid discharge and solid reclamation. So these 4 sectors will be the futures, and a lot of technologies will be involved in this. So it's not only about technology. Business models must evolve to meet the challenges of the 21st century. People and process must evolve. What we can see here happening in Morocco, and I can tell you because I'm worldwide looking what is happening, it's a very unique project what you are doing in Morocco, and I think we have to congratulate you for that. It is really unique that you can do all that in this time, and that you are trying also to have all these sustainability features in your program. And of course, regulatory policies must be re-evaluated, and we have to encourage this application of novel technologies, because these novel technologies are not cheap. So somebody has to invest on them, and they have to invest in large scale. So the path to sustainability is that technology and the vision can go to the sustainable solutions, and we will be happy to see all this project of OCP and to be part with our engineering and with our technology as a company which is starting from engineering and ending up to operation to cooperate and build this kind of projects in Morocco. Thank you for your attention.
Thank you, Dr. Alex, for sharing with us your contribution in OCP Group program, water program, and also give some insight about the trends, about your realization and experience around the world. So now I will ask Mr. Patar from Ion Exchange to join this, to present their contribution on the OCP water program. Patar is the senior Vice President, International Division of Ion Exchange, which is specializes in water and wastewater treatment, using a wide range of technology products and process to provide integrated solutions for total water management from the industry, communities, and homes. Mr. Patar is a chemical engineer and also holds a management degree. Before taking up the assignment of a head of international department, he has had various management positions and has 4 decades of experience in water and environment management. Thank you, Mr. Patar, for being here. Here you are.
Good afternoon, OCP and good afternoon. Yeah, I think that is. That's right. Good afternoon, everybody. Yeah. Thanks for giving this opportunity, and thanks for being a part of OCP Green Water. In fact, I will not cover the traditional, what we do and all those things. I will showcase the thing which we have done in the unconventional water resources and how exactly we have explored the water requirement. Incidentally, the problems which Morocco has, the India also has the similar problem. We also are short of water. We have the water, but somewhere we have a very bad contamination like arsenic, fluorides, So we need to have, a lot of solutions for the society. And being committed to, the society, we go on innovating a lot of things with respect to the water purifications. So I will cover water, unconventional sources. These are the couple of the statistics in the world. As you know, all of us, that water is a big shortage across the world. It's not only in Morocco or Africa. As I said, India, we have a problem. Indian subcontinent, we have a problem. So the efforts are being done to see how exactly we actually reuse the water and use maximum water available with the resources. So why there is a shortfall of water, actually, I will say. First is the less fresh water availability. There is no stringent pollution controls in many of the countries, because people just throw the water, even if it is proved, they just throw into the river and lakes and spoil everything. There is a very less awareness about the wastewater treatment among the all industry leaders as well as the community. So people don't think that wastewater can be recycled back for the industrial use, also for the human consumption. And I will say the very, very dangerous thing is the potable water is used for the industrial application. And time has come where the potable water should be used only for potable, and industry should be forced to use the recycled water. So just to go by the traditional water sources, which is all of you know, mainly source of rivers, ponds, lakes, surface water, the underground like wells, springs, etc. The emerging sources, which I am sure OCP and JESA is maximum used, is seawater and brackish water. And now I will not say it's emerging water, it's become a common sources. But what is the 10 years, last 10 years, the progress has become? The industrial wastewater recycle has become the major phenomena in the world. I will showcase a couple of the things which we have done. The sewage recycle, Singapore is one of the biggest reason, the showcase for such sewage recycle, portable reuse, and of course the aquifer storage recovery. There are other water resources which is being explored now worldwide. The rainwater harvesting, in fact, in India, especially in the city where I stay, Mumbai, the local governance has made it compulsory that all the new societies or the buildings, the apartments which are coming should have the rainwater harvesting. Otherwise, they will not give any certification. Now people are talking of dew and fog water harvesting. Even the agriculture drainage recovery is being thought all over the world, and Africa is one of the good example of that. And networking of water sources. I saw one slide from OCP. It is being done there. In India also we have started the networking of all the rivers across each other, so that where there is a scarcity of water and if you have floods, the water can be diverted to the other area. Now, what are the alternate established sources? Of course, desalination, MSF, MED, and vapor compression. That is being used in the Middle East, more of a thing. And the reverse osmosis, which all of you are very familiar. Now, there are certainly advantages because the seawater is abundantly available, but and then there is a consistent quality also. You don't have much variation. Maybe you can say 10% of thing. And modular design, which Mr. Rosin also briefed in his presentation. The modular design allows all the companies to go very fast on the implementation. These are certainly the advantages of the seawater. Now, what are the challenges? Well, reject, recycle, disposal is a big problem. It is being faced all over the world. I have attended many seminars where people talk whether reject disposal, how it should be done, it should not be done, all those things. There are a lot of issues being discussed globally. The power cost is another big thing in the seawater desalination, and the critical monitoring of the pre-treatment plant. In fact, if you don't do the proper monitoring of the the pre-treatment, certainly there will be a lot of problems in the reverse osmosis plants. And what is main concern is the permeate recovery. Today we are talking of 50, especially in the Morocco. It is varying between 45 to 50%, but now people are talking of 65, 70, 80, like that. So these are the main challenges, and which I am sure in a time to come, OCP, JESA, we all their partners will have to think in this type of these things. Well, dispose of the RO projects, there are a couple of things which are being done. Well, they are disposing out without anything into the sea, but it really affects the marine life. It affects the coastal area. But in the inland, what they do is there is a solar evaporation being thought, but that is not for the big project. It is being done on the smaller thing. I will show you a couple of examples which we have done. And of course, the thermal evaporation, which is the other thing which is being done. Now, what are the disadvantages of solar evaporation? In fact, it requires a large area. We tried similar thing in Jordan, but of course, we could not do it because of the area required there. Then, of course, the lot of the challenges with respect to the atmosphere. If you have a low humidity and sort of a sunlight issues, then there is a problem with this kind of option. And of course, not viable in the places where you have a heavy seawater, the rainwater. And in such cases, the thermal evaporation is the only option which is being thought all over the world. Well, there is also high recovery reverse osmosis plant, the membranes, which is being done, and couple of the membrane manufacturers are doing research on that. We are also one of the membrane manufacturer in India, and we are also doing a lot of research on the high recovery RO plants, the membranes I mean. The major, what is very important today, which is being covered by both, Mr. Dimbar and Mr. Bosoni, is wastewater recycle. See, in fact, if our company's vision, we always say we have a 360 water management, so we try to always see that how best we can pass on the benefit to our customer by recycling maximum water which is being coming up from the thing. And in fact, it's more of a sustainable value it carries, because you have the the influent less water, and you can conserve a lot of things. You can use this water for the industrial application, and we can go for a zero liquid discharge, which again I will display in my next subsequent slides. And of course, the environment and responsive solution is very critical for this. Now, what is the benefit of this recycled water? In fact, it doesn't require much energy. It's more energy intensive. It's less energy consumption. The variable cost is much lesser than the seawater if you have water resources, and if you put a reverse osmosis plant against the recycle plant, the cost of recycle plant, the operation cost will be, or the even life cycle cost will be much less. In fact, it is the most sustainable alternate water sources. It's one of the, now most, I will say, talked about and implemented across the globe. And there is a positive impact on the environment, because actually you are using, everything back to the system. And again, the civil cost is much less compared to what you do for the reverse osmosis plant. Now, even we have done the RO for the recycle. In fact, a couple of plants like cooling tower bleed off, the 2-bed systems which we are using for the, using resins, or a boiler blowdown, we have the case histories where we used RO plant for the recycling this water back to the process. And so the main aim is to, recycle as much water possible as what you can do. Now, we just don't talk actually. We do in our own factory. We have 2 very big chemical factories. One manufacturing the resin, ion exchange resin systems, and other we do a lot of chemical production for the polymerization and all those things. So this is the schematic. I will not go into detail, but the plant at our chemical factory, we are doing the zero liquid discharge and complete recycle of the all effluent which is generated from our plants. So we want to showcase by the world that we do first in-house, and then go and tell the people that this should be done or this can be done. And 2 case histories I will certainly clear here. This is the Indian synthetic rubber, where it is an Indian oil, again oil refinery, and then we have the Taiwanese partner and Marubeni Corporation. This we have done complete the primary and secondary treatment. And of course, again, I don't want to go into the schematic, but it can be shared if anybody wants to have. And then we have a finally zero liquid discharge. So this plant totally is zero liquid discharge, which we have done 10 years back. And Reliance Industries, some of you may be knowing, this is one of the largest the petrochemical company, or biggest company in India, I will say. So we have implemented complete zero liquid discharge plant for their system also. We have a primary, secondary system, followed by tertiary, and then ZLD system. So these are the 2 case histories where, in fact, totally we have 35 plants in India and Middle East. We are done for a fluoride removal system also in Abu Dhabi. So I think my appeal here through OCP and JSI is, certainly we will go ahead because of the water need of the desalination and the society, but all of us as a team should also look for the wastewater recycle and zero liquid discharge. I think that's all from my side.
Thank you, Mr. Pathar. So now I will ask our last, and not least, panelist, Mr. Igor Galindez from Fluotech. Mr. Igor Galindez is the commercial director of Fluotech, in charge of global sales and marketing, passionate about the water treatment industry, introduction and development of new businesses opportunities worldwide, and international promotion of genuine proprietary technology. Mr. Igor has a strong experience in water treatment field, with a strong daily focus on RO, prefiltration, either conventional or UF membrane based. Thank you, Mr. Igor, for being here.
You have
you will have the PPT presentation.
Thank you. Well, first of all, thank you for your introduction. Thank you all for your assistance here. It is a pleasure for me to be part of this event together with OCP, YESA, and industry colleagues as well. Well, I will talk to you about a decade of success and some key milestones in this enduring partnership in which we have been successfully being involved since 2014. I would like to introduce briefly Fluidtech for all of you who do not know yet about us. We are a Spanish engineering and manufacturing company specialized in water filtration technologies and equipment, with a strong focus on everything related to pre-filtration, especially before the seawater reverse osmosis membranes. The company was founded in 1979, and we do currently have factories in Spain and Portugal. We are proud to say that nowadays Fluidtech is the company with the largest filtration installed capacity in the market, in the global market, totaling more than 35 million cubic meters a day of RO product. We do cover the whole globe. We have a worldwide presence, and as a matter of fact, we are currently exporting more than 90% of our production. As we are a filtration company, we try to divide our offering depending on the filtration spectrum. And in this sense, we can work in macro filtration, focusing on removal of bigger particles, micronic filtration, the conventional cartridge filter housings, and other alternative technologies as well, and going down to the ultrafiltration that will be today the main topic of my speech. Our portfolio is huge and extensive, and as I mentioned before, is mostly focused on everything related to pre-filtration or pre-treatment before the reverse osmosis. Every project in which there is a reverse osmosis system, Fluidtech can participate by adding experience and technologies. In this case, our main cooperation since 2014 with OCP and YESA has been about ultrafiltration. Okay, we started back in 2014 by building customized factory build systems. Okay, and now I would like to share with you all the background and all the trajectory that have put us in the current position, for which we are more than happy and proud of it. We started working in Jorlas Far 1 project, roughly 75,000 cubic meters a day capacity. Okay, our role as a company at that time was merely to execute and manufacture and deliver the UFS kits without the UF modules. And at that time we provided just with the workmanship warranty, because we separated the modules from our scope. This plant is Jorlas Far Phase 1, with a total capacity net plant production of 25 million of cubic meters per year. I mentioned this capacity in two different ways, because usually in Morocco they like to explain the capacities in these figures. Later on, almost 10 years later, we had the opportunity to be involved, even going one step forward and delivering the complete ultrafiltration system in a plug-and-play basis, including the modules, also providing with the complete performance warranty. This was for us at that time a key milestone, because to be honest, it was very challenging. We managed to successfully deliver this, and I'm very, very glad that all my colleagues, all our team was totally involved in delivering on time and in the right manner. And thanks to the performance of this key milestone, we are now in a position that allows us to be part of all the other expansions and future projects. Nowadays, we are executing Wave 2 West project, one of the projects mentioned by other panelists in today's session. In this project, we are delivering only the UF system. This is a huge project, totaling 250,000 cubic meters per day. In other words, and in order to tell it in a different way, this is 80 millions of cubic meters per year of net plant production of the RO system. After that, also in the same year, and with one of our partners, and also sharing this session with me, we are now under construction of more skids of Wave 2 East. That is the other key project that is running nowadays. I forgot to mention, but for the first Wave 2 West, 250,000 cubic meters per day, we have already delivered 4 UF trains. The UF trains are huge, are probably one of the biggest UF trains in terms of number of modules available in the industry, and this is something remarkable, and that I would like to explain a little bit deeper in detail later on. Okay, we are now scheduling delivery of 4 skids of with a capacity of up to 100 UF modules every 2 weeks. So I think that this will totally meet the expectations of both OCP and YESA and the country's need of water. What is next? Well, nowadays we are also involved in the last stages of finalization of the Wave 2 East 2 project. Also same capacity, 60 MLD, 60,000 cubic meters per day plant, with also one of the panelists here. And also involved in developing some innovations to be implemented in other plants that are also in need of a fast-track delivery and a fast-track implementation of a solution that can allow to have access to the water that they need for the projects they have in mind. I would like to add that the total UF installed capacity of Jorlas Far, after all this, will be totaling 1.4 cubic meters per day. I would like to put a special emphasis on that, because this is nothing that can be found in other countries in the world. I'm not sure if any of you know any other plant driven by seawater reverse osmosis membranes with ultrafiltration as pretreatment that has this huge capacity. This is admirable and remarkable, and indeed I think is one of the biggest plants with a UF pretreatment based on seawater reverse osmosis in the world. Some brief achievements of Jorlas Far, the previous success cases. Okay. This is, according to our research, the largest UF pretreatment plant in North Africa with seawater reverse osmosis system membranes. And after the current expansion phases, we'll have by far the largest combined UF pretreatment in the world, as I mentioned before. This is not only the biggest, but also the one that is running properly from an operational point of view. That is at the end the challenge and the target of all of us when we are involved in these projects. This is definitely a flagship of successful operation, an example of super fast track execution, and this modular way and kind of standardization based projects are allowing all of us to multiply the capacities and to execute multiple and numerous projects at the same time in parallel lines. This is a remarkable reference in industrial and municipal waste management model. Well, coming back to the past, success cases, as I mentioned before, the Jorlas Far, roughly totaling capacity of 75,000 cubic meters per day of UF pretreatment. You can have a picture there. The membranes used here were delivered by DuPont. And at this time, we just started working on this concept of modularity, simplicity, customization, and later standardization to allow repetitiveness. And I'm happy to say that this humble starting point has allowed us to be present right now, not only here, but also in these very, very nice projects. We started with plug-and-play UFS kits, and after some years with the Jorlas Far 2 expansion, we got bigger in terms of project management. We also included the membranes in our scope of supply, also providing with a performance warranty and working directly with YESA and OCP in a seamless collaboration. For this second chance to participate in these UF projects in Morocco, we improved the capacity and the production. I think that this also helped to be even more present on these challenging opportunities, and we do expect for the near future to be able even to improve more if it is possible or feasible. I would like to give special thanks to OCP Green Water for inviting us to be part of this great event. And well, I hope you enjoy the event, the show, and the island. Thank you very much.
Thank you so much, Mr. Igor, for being here. Thank you to all speakers and panelists. I don't know if there is any question in this, yeah.
Thank you, Lamia. Thank you for the very instructive panel and very interesting discussion we'll have. I have a question. The Green Water Program for the ECP is really huge and impressive. My question, and it relies on huge infrastructure and I believe also on new technology important. So how is the cost of the new technologies important, and how do you evaluate the return on investment?
Thank you.
Yes, it's working.
Thank you for your question. Thank you for the question. If I understand well your question about cost of desalination and infrastructure. As you know, for the implementation of desalination plant, we launched tender, and we tried to have the best bid in terms of cost. And we have tried also to target the new technology, like technology who allow to save more energy, because the energy in the OPEX, it's around, the part of the energy in the OPEX, it's around 50%, 50%. That's why also we target to have the technology with high saving in energy. And also we try to target the technology who can achieve high recovery, because the recovery is linked, is highly linked to the cost, to the global cost, capex and opex. I don't know if I answered your question, or thank you very much. Okay. Yes.
So it's a very, very pertinent question, Madam. I think there is, stages. There is a stage, as mentioned by Mr. Zneiber. We have been working to answer an urgent need. And answering an urgent needs means that we have done some, not to say concessions, but we have been able to, to supply and put into implementation, some solutions, modular solutions, as I mentioned earlier, that allows us to go faster and to deploy faster the facilities, but also modular that allows us to save energy, to do more energy recovery, but also allows us to have facilities cheaper than the conventional ones. Now it's all lessons learned for us. We have made this leap of answering the urgency. Now we are making another leap to take into account all the experience, all lessons learned. We are working today on wave 2 to even optimize the facilities, having more standardized facilities, because the first wave was like, let's say, a mix with all modulars which either are containerized or skyded, but which gives us a lot of experience in terms of managing the facilities. For me, it's like a labo that we have now at Jorf at Safi in terms of desalination. Today, as I said, we are going to another waves where we are learning from our experiences, where we are working on energy recovery, where we are also working to have this zero liquid discharge. So for us, recycling also is something that we are working on, to have more seawater recycling. We are working also maybe in near future to manage the brine. There is a lot of technologies that we are today exploring to manage the brine and see at which level we can also reuse even the brine or re-inject it in the seawater. And of course, and this is for me the most important, is to efficiently manage the input from the sea, because the sea, you have the perturbation, we have a lot of things. We are working on some cases to put in place the right pre-treatment system, whether it's sand filter, whether it's decontamination, whether a lot of research and development that we are doing even with UM6P, thanks to UM6P and also to other stakeholders working with us. So it's for us a journey where we are putting in place what we have been able, and we are proud of, to being able to answer the need, and today OCP is autonomous, alhamdulillah, thanks to what we have been doing, and also to contribute efficiently in the urban development. Safi and Al Jadida are 100% fed by our facilities, and we are aiming to do more. So this is something that we are improving, to have more cost effective, and I think this is something that we have learned, and also our ecosystem is also developing its capability based on what they are learning, what they are experimenting with us on this huge program. I think it answers your.
Thank you, Mr. Bouziane. I don't know the other panelists. They want to add something. Yeah.
Yes, it is only to add something about the cost of the water, because it's a very popular question, not nowadays, but a traditional question in this our industry. Just consider that the cubic meter of desalinated water nowadays has a very, very, very low cost. The energy efficiency is always better and better and better than ever before, and I think that all the participants in these industrial challenges, we are always trying to optimize the flow distributions, the energy consumption, not only in the designs but in our day-to-day work. This is a philosophy shared with other colleagues as well, and I see that there are some people that are external to this market, that they always believe that the cost of the desalinated water is a problem. But indeed, I challenge you all to really make the maths and make the account how cheap is nowadays 1 cubic meter of desalinated water. It is not a matter of capital expenditures. It is not only a matter of capex. It is also a matter of how is the operability of the plants, how long will your plant last. in over the time, and how efficient you can produce the water. So I invite you all to learn more about that, because the maths are, in my opinion, very clear, and I'm sure that my colleagues in the industry and our partners are of the same opinion. That's all I wanted to add, and thank you for the question, because it is very popular, but still needed to explain this. Any other questions? I also would be happy to.
Thank you,
to
Mr.
answer.
Igor. Mr. Patar wants to add.
I just want to add one more thing. In many areas where we work in India, the government authorities have stopped giving the fresh water for industry. It's a mandatory now. You have to recycle the water for your operations. The water will be given only for the drinking purpose, for that purpose. Even the wash water and toilets, everything has to be recycled. That's a compulsory. Otherwise, they don't give the the license. The second thing, as he said, as well as Mr. Buzian said, today the evaluation is done on the life cycle cost. It is never done on the capex or operating cost. So we decide what is the life cost for any plant, and the comparison is done on the life cost, life operating cost, they can say. So it adds capital as well as the operating cost for 20 years or something, and the replacement cost. And that is how it is being evaluated, rather than just capex or the day the plant starts the operating cost. So there is a big change now happening across the globe, I will say. Thank you.
So, thank you. Yeah, there is another question.
Merci. Permettez-moi tout d'abord de remercier nos collègues de l'OCP et du très beau travail qu'ils sont en train d'achever et du programme qui est mis en place. En fait, j'ai une petite question pour le dernier intervenant. C'est la durée de vie réelle des filtres, des microfiltres, et la durée est celle que vous considérez dans le calcul du CAPEX. Deuxième question, c'est quelle est la limite de l'efficacité d'usage de ces microfiltres? C'est-à-dire, si nous avons une houle médium par exemple, est-ce qu'elle a un impact sur l'utilisation ou sur la durabilité de ces filtres? Merci.
Je sais que Igor a compris parce qu'il parle en français. But maybe you yeah, okay.
We're waiting for the translation first and repeat the question, I think.
Allow me please to reply in English. I got 75-80% of your question. Maybe my colleagues and partners can help me out if possible. But about the capex, the capital expenditures are like the competitiveness of a product or a technology. You know, it is always a matter of a good balance in between price and reliability and performance. So sometimes many end users and many EPC companies are focused mostly on pure capex, and after some years they realize that all the money they saved in the capital expenditures, it will be expended over the years of operation. So only those companies that has the necessary experience over the years will realize that it is sometimes even more important to have a sustainable operation rather than having the lowest capex available in the market. The capex is very good for today, but it's not sometimes the best for tomorrow. I'm not sure if this first question of yours has been properly answered or not. And the last part, to be honest, I do not remember. If you could repeat the second question, no? I would be glad to try to reply to it.
The first question is about the cycle life duration for the UF.
Yes.
10 years, 20 years, and what we use in the capex, when we use the capex for amortization. It's 20 years, 15 years.
Okay. About. Sorry. Hello? Hello? Excuse me. Excuse me? Okay. About the durability of the membranes, well, I will speak about the UF membranes itself. A premium manufacturer of UF membranes can offer performance warranties of even 5 years, because it is well known that there are some plants that are operating successfully without fiber leakages and without significant modules replacements for more than 5 years. I'm pretty sure that my partners from GESA and OCP knows better, much better than me, how long can last a well-built and well-operated UF system. Because, of course, at the end of the day, it is also very important, a good operation, a good knowledge about how to do the proper cleanings, the chemicals to be used, the concentrations, and that's why we have experts in chemical engineering that can add their value on all these projects and opportunities, not only the past, but also the current and the future ones. Maybe Alex can.
Yes. Just to elaborate a little bit. Okay, there are some standard guarantees. How much time? What is the life of a membrane, either for reverse osmosis or for the UF? So the manufacturers, they give a typical lifetime. For the membranes, for example, reverse osmosis 3 years, the guarantee we mean, and for the UF is 5 years. But we all know, and the reality is that according to the operation, the UF modules, they can last. Normally you have to put it in the business plan that a good plan will last at least 10 years, the UF modules. And for the for the reverse osmosis membranes, the typical life is approximately 5 years. But in many cases, we have seen also plants that it can work much more. We replace the membranes, and we replace membranes, which is a big cost also, only when they don't perform anymore in the right characteristics that we want. For example, if they consume more energy, they block and they consume more energy, so then it's better to replace them, or they don't provide the right quality. But right now, the truth is that the new materials and the new membranes from the well-known manufacturers, they can have a lifespan which most of the cases is close to 10 years. And this provides a very good financial benefit to the plant. One more thing just to elaborate is that modular plant is something that all the speakers say here. When you make now a plant, in the future, in the past, you had to bring all the work to do it on site. This was very time consuming, and actually it was increasing the cost and gives also a lot of problems sometimes in the quality. What is right now the tendency, and what in Zoslafars is more and more used, is the modularity. That means that the plants are pre-assembled in a factory, are tested, they can have some very good quality tests, and then move and reassembled on the site. This process provides a very big benefit on quality and on the cost, because finally it is more cost effective to do it like that and save time, and time is also money. So this is the way that this amazing example right now of how this fast track are moving. It will be impossible to move these fast track projects and try to build the plants on site. So this is one of the secrets. And as much as modularity is becoming more elaborated, that means that the plants will become cheaper also. Because when you repeat modules, of course these modules can become more cost effective. Of course, there is always the case that modules have to be designed correctly and have to be assembled in a professional way, but after you achieve that, it's a very economical solution.
I will use this one. The second point, I think the question, it was about the impact of the wool on the filtration equipment or units. The wool.
The impact.
The impact.
The impact of this.
Use this one.
the impact of the soil on ultrafiltration operation. You understand? You understand?
Please use this micro.
You mean the squid? You mean
Please, Doctor. Yes, this one here.
You mean the water coming from the sea, that you have a lot of squids and this kind of, yes. Okay, this is a phenomenon that we have. Sometimes we have also algae. We have sometimes that a lot of organic material is coming from the sea. And of course, you need to have a pre-filtration system also, because you cannot go directly to the UF modules, so you need to have to elaborate a pre-filtration system to extract this kind of materials, let's say. So the filtration is not only UF and RO, so it's only the UF skid, so you have to elaborate on how you will take the seawater. It's also very important, so there is technology and you have to develop the seawater suction, what will be the depth of the pipe, where the pipe you will put, and how you will bring the water. This is very important. And of course, some pre-filtration with screens and so on to avoid this kind of phenomena. Of course, to be very honest, there are cases that when these phenomena are extreme, like you have the climate change, okay, if you have an extreme phenomenon, of course, for these days, sometimes plants have to shut down. This is something, unfortunately, that we all experience, or not shut down, but they have to stop, or because they are blocking, and then you need time to unblock them. In this case, modularity is also very, very critical. That means that you don't have one train, you have many trains. So when you block, you can clean one and operate the other one, because what is causing this effect actually is blocking your lines that you have to stop and start, so you are not losing your capacity if you have a multiple number of lines. So this is the way to deal with this phenomenon. There is also right now artificial intelligence, also algorithms to predict this phenomenon and try also to prepare the plant so that you are prepared for this kind of phenomenon, and try to avoid extensive blockage, because this kind of phenomena can also provide damage to the plants. But it is what the gentleman say also, you have to learn, and you have to take the experience. There is nothing, and every sea and and every location have some particularities. It is not, the sea is not the same everywhere. So you have to get the local experience, and this is also very important. That you are getting this experience in George Lafarge.
I think, Alex, in addition to what you have mentioned, I think today OCP is also, thinking to invest more in some facilities when it comes to intakes from the sea. OCP today has open intakes, but for SAFI cases, we are working to launch offshore intakes, which will minimize this, this phenomena of having algae, of having, perturbation on the sea. So intake offshore will be like a sinking offshore that will be in 800 inside the sea, which will bring us more, let's say, fresh water and will protect us from this, this extreme situation where we are facing, some perturbation on the sea. So this is something that we are also exploring today.
Juste pour compléter un peu la réponse par rapport à la question de M. Zerouali, les filtres ou les filtrations ou l'ultrafiltration sont designés par rapport à un niveau de composition et de pollution de l'eau de la mer. Ils sont dimensionnés généralement à 90% par rapport aux cas extrêmes. Maintenant, une fois les cas extrêmes arrivent, donc lorsqu'il y a une houle exceptionnelle, avec une pollution, je dirais, agressive, pour moi, je pense, ma proposition, et compte tenu de l'expérience, c'est carrément d'arrêter les installations de dessalement. Sinon, effectivement, les membranes elles sont crasses d'une manière très importante, Et pour qu'ils retrouvent leur, je dirais, rendement, il faut du temps d'entretien et de maintenance. Et je dirais, des fois même, on perd carrément la qualité des membranes, c'est-à-dire il faut même les remplacer. Donc, pour répondre, oui, la houle exceptionnelle a un impact déterminant sur aussi bien la durée de vie que sur le rendement des unités de filtration.
Je ne sais pas s'il y a d'autres questions. Donc, on clôture l'événement. Thank you so much for being with us. Thank you to attendees. Thank you to the speaker, valued speaker, and see you tomorrow. Thank you.